Welcome back. So as I mentioned a couple videos ago, there's more than one way of implementing a stack. It's just a general idea of a data structure where we can add data in and remove data using a last in, first out principle. LIFO, LIFO, the last thing that's added in is the first thing we get back. And I showed you how to do that using an array. And that works. We didn't have to write any new code. We didn't even define a class. We just used an array and used the built-in methods we get for free. Nothing wrong with that. It's a little heavy-handed. We don't need, indices, for example, which we get for free. We don't need all the other, dozen plus methods that an array comes with. We don't need any of that. All we really need are the methods to add and remove in a last in, first out fashion. So what I'm going to show you in this video is how to build our own stack class that doesn't use an array at all. In fact, it's built kind of following the principles of a singly linked list. So if you didn't watch the section on singly linked lists, you should go back and check that out. You could also do it with a doubly linked list, but I'm not going to do both because it's a lot of time and it's very similar. And if you see how it works with a singly linked list, you'll get it with a doubly one. All right, so one note. When we use and learn other algorithms later on, some of them use a stack and queues, which we'll see in a second, to help them out, to store data, sort of to keep track of what's been processed and what has yet to be processed. And we could use an array implementation. We could use our own class. To keep it short, I will be using an array implementation. That doesn't mean it's better, though. It's just easier and quicker. But this is the stacks and queues section, so I'm going to show you how to make sort of the best possible stack from scratch. And it should work or look like this. I should be able to initialize a new stack. And there's only two methods we care about, stack.push and stack.pop. So I could push something like first and a couple more second. Notice it's returning to me the size or the length of it. And then let's do one last one. And then when I pop, it should, of course, follow last in, first out. So it gives me fourth, and then third, then second, then first, and then null. So that's it. We need a class defined called stack, and it needs a way of storing data. So we'll have a node class as well. It looks like this, just like we did with the linked list. Instead of head and tail and length, I went with first, last, and size. Head and tail is usually reserved for a linked list, even though this is a subset or a special case of a linked list. I like to use first and last, but it's the same idea, head and tail. They're just pointers, they're variables. And then we have the node class that has a value for each node, and then a pointer to the next node in the stack. So at this point, you might be thinking, well, we already built a singly linked list. It had a bunch of other methods, but it had push and pop. So why not just use push and pop as they are? And that could work, except for one small problem, which is that in a stack, push and pop are supposed to be constant time. And if you remember, if you didn't watch the singly linked list section, this probably won't make sense, but pop in particular was not constant time. Because to pop something off the end of the list, the way that it works, we have to iterate over the entire list and stop one node before the end, one node before the tail. That's what this code is doing here. So this is not constant time because we have to loop over the entire list. So instead, it's much better to use shift and unshift, except they're supposed to be called push and pop. So I'm going to show you, I'll actually write the code, but hint, hint, you could basically just rename shift and unshift to push and pop and call it a day. But I'm going to define my own stack class right now. I do have pseudocode if you want to do this on your own, but I didn't want to drag it out into multiple videos. So basically, push is going to work a little differently than push that we wrote earlier on, because we're going to be adding to the beginning of the list and removing from the beginning of the list, instead of adding to the end and removing from the end. Same idea, it's just that when we add and remove from the beginning, it's faster, it's constant time in a singly linked list. If we use a doubly linked list, then it wouldn't really matter. It would be constant time to pop as well from the end. Anyway, so we'll define a function called push, and it should accept a value, create a new node with that value. If there are no nodes in the stack, set the first and last property to be that new node. If there is at least one node, create a variable that stores the current first, and then reset the first to be the new node. And then all we need to do is connect everything together. So set the next property on the node to be the previously created variable, and then increment the size by 1. So I'm going to come over here and define first I'll do my node class. So node is really simple. It's copied from before. We have our constructor. I'll fast forward. It looks like this. Value, we pass in, we set this value equal to whatever was passed in. This dot next starts as null. Then we start with our class called stack, which also is really basic at the beginning, doesn't take anything. And instead of head and tail, I'm going to set first to null, last to null, and then also I'm going to go with size instead of length, just to differentiate it. And it starts at 0. Okay, so now to push in, it needs to accept a val. And then we create a new node with that value. So let's just do var new node equals new node with whatever was passed in. Then we check if there are no nodes in the stack, set the first and last property to be that new node. So we'll just check we could check if the size is 0 or just if there is no first. If there's nothing at the beginning, we set this dot first to be the node, the new node, and then do the same thing for this dot last. All right, so that's that. Next, if there is at least one node, create a variable that stores the current first property on the stack, and we can go from there. So we need to have an else, and I'm just going to make a variable called temp equals this dot first, the current first, because we're adding this to the beginning. Then we're just going to say this dot first is now equal to new node, and then this dot first dot next equals temp, the old beginning. And then the very last thing we need to do is increment the size of the stack by 1. And I didn't actually add this in the pseudocode, but I explained this earlier that it's best to return the size. So I'm going to do that in one line, just return plus plus this dot size. And if I run my code, I should be able to do var stack equals new stack and do a push. Let's just push some random numbers in. Looks like, well, we can't actually tell if it's working, but at this point, the order in that stack, the first very beginning should be 2301, and then that should point to 230, and then that should point to 23. So now we just need to implement pop, which will remove from the beginning, which again, we're doing it backwards, sort of counter to what we did with a singly linked list, because we want constant time for adding and removing, for pushing and popping. So now to implement pop, we're going to define a function called pop, and we're going to check if there are no nodes in the stack. If it's empty, return null. Otherwise, we're going to take whatever the first property is on the stack and store that in a variable to return at the very end. Whoops. If there's only one node, set the first and last property to be null. Meaning if the first is now equal to the last, set the last and first to be null. If there's more than one node, set the first property to be the next property on the current first, decrease the size by 1, return the value of the removed node. So you could pause it if you want to implement this on your own, but again, these two are very similar to shift and unshift on our singly linked list. We're just using first and last and size instead of head and tail, and we're naming them push and pop. Okay, so pop. First, we're going to check, what was that? If the list is empty. So I'm going to do if not this dot first. If that's the case, return null. That means there's nothing to return. We're done. Or there's nothing in the stack to pop. Otherwise, I'm going to take, I'll call it temp, set that equal to first. This is what we'll return at the very end. And I'll actually do that now. Return temp dot val, or value. So we're returning the value at the end, but along the way, we need to patch things together. So we want to check if there's only one node, meaning if this dot first equals this dot last, what do we want to do? This dot last equals null. And that's just an edge case. When there's only one thing left in there, we need to make sure we're also updating last, because on this next step, we're going to update first. This dot first equals this dot first dot next. So we needed to do this beforehand. If it's the last thing in this list or in this stack, we need to make sure that last is null, so that when we do this.first equals this.first.next, we're setting first to be null as well. But in the case of this example where we have 3 things in our stack, we're not going to change last to be null. Instead, we're just updating first. And then the only other thing, we need to decrement size. So this dot size minus minus, just like that. And we should be good to go. Let's test it out. So let's make a new stack. Var stack equals, no, that's not supposed to happen. I thought it was going to autocomplete for me. Stack.push. Let's do first like this, second and third. Sorry, my cat is making a lot of noise over there. What are you doing? And then we'll do stack.pop. We should get third, and then second, and then first, and now nothing. And we have successfully implemented a stack. So hopefully you did watch the singly linked list section. Otherwise, this would be a complete whirlwind, and that's not my intent. You're not supposed to see this unless you went through that first section, because there's a lot of stuff here that I'm not explaining. Anyway, so just to reiterate why we did it this way, rather than using push and pop that we already wrote for a singly linked list, just to reiterate, remember, if we're adding to the end and removing from the end, it's not constant time to remove from the end, because we had to iterate the entire list to get to the second to last item to set that to be the new tail. And a stack is supposed to be constant time, so we're adding and removing from the beginning of our list, but we're calling it push and pop because it is a stack. All right,